Okay, in our class today, we are going to be solving a question on kinematics. Now, in this question, you are given that the displacement f in the respect of t of a car as a function of time t given as f in the respect of t equals 3t squared minus 2t plus 1 in bracket meter. Find its velocity at time t equals 4 seconds. And the question now says, at what time will the velocity of the body become 0? So we are given two questions in one. First thing is that what is the kinematic equation? For every kinematic question, there's always a kinematic equation. And the kinematic equation in our question is this, which is f in the function of t equals to, in bracket, 3t squared minus 2t plus 1, closing the bracket, n. So the first thing we need to do is to try to write down the kinematic equation. Now, isn't that the kinematic equation? Now, when you look at the kinematic equation, is it acceleration, is it velocity, or is it displacement or distance? How will I know? This is because here is left as meter. Anytime we have a kinematic equation and meter is using here, it means it's a distance or displacement kinematic equation. I believe it was left in meter per second. That means it's a velocity kinematic equation. I believe it was meter per second square. That means it's what? Acceleration kinematic equation. But the question here says that we have meter. So since it's meter is what? A meter, a distance or displacement kinematic equation. Now that means our f is our distance. The question is asking us to find velocity at 4 seconds. Now there are two kinds of velocity. First thing we have what we call average velocity. And we also have what we call instantaneous velocity. Now the question is, what's average velocity? Average velocity is the total velocity that is done in a motion. The total velocity done in a motion is called average velocity. As you can see the formula, sometimes you can try to write it by putting arrow and putting a subscript AD. The essence of this arrow is to tell you that velocity is a vector quantity, and the subscript AV is telling us that the velocity is an average velocity, and the formula for that is just your change in s over change in t, where change in s is called change in velocity and change in t is your what? Change in time. Looking at this carefully, we have xf minus xi. Anytime we use the word change means the final from the initial. So that means final minus initial, final minus initial. That's the formula for formula for average velocity. But when it comes to instantaneous velocity is a velocity at a particular time. Velocity at a particular time. Look at our question. It says its velocity at time. That means the time here is being specific. So that means from formula for that we say our instantaneous velocity, we can put it as INST to represent instantaneous, is equals to the limit of your change in t tends to become 0 when you have change in s over change in t. Now what does this actually mean? It means that my function of t is turning to become a particular thing. That's the essence of why we have change in t tends to become 0. That means it's going to a particular time. And for us to do that, this can be written as the y over the x. So for this case, we are not going to call it the y over the x, rather we call it the s over the t. So this is the formula we use anytime we are given instantaneous velocity. So it means anytime I'm given instantaneous velocity, I have to apply differentiation. So looking at this carefully, I'm trying to get my velocity at 4 seconds. For me to get my velocity at 4 seconds, I need to find the way to differentiate this. When I differentiate this, then apply the time when it's at 4 seconds. So how do we differentiate? Quick one. Under differentiation. In differentiation, if I have a kind of equation that says y equals to x in the power of n, anytime you are differentiating, all you need to do is that you bring this what your n to the back, when it's brought to the back, you subtract 1 from the power. So that means my dy over dx is equal to n is brought to the back, then s in the power of n minus 1. That's how you differentiate. So beginning by s in respect of t equals to 3t squared minus 2t plus 1 in meter. And I want to get my dx over dt. To do that, it means my t square will come to the back. So that means I have 3 times 2t, subtract 1. That's 2 minus 1. Then minus 2. At this side, we have the power of 1. So when I bring the 1 to the back, I'm going to have 2 times 1, then t, 1 minus 1. Plus, anytime we are differentiating a constant, now let's assume, okay, anytime we differentiate a constant, we assume that there is a variable there, which is t equals to 0. So when I bring the 0 to the back, that means 1 times 0, then t, we have 0 minus 1. So going on with this, I'm going to have 3 times 2 will give me 6t, then 2 minus 1, that's 6t, the power of 1, minus 2 times 1, that's 2t, the power of 0, plus 1 times 0 is still 0. So I have 0t minus 1. So at the long run, we're going to have 6t minus 2 because 2 in the power of 0 is 1, 2 times 1 plus anything multiplied and turn to 0. So it's 6t minus 2. That is the kinematic equation for the instantaneous velocity. So let's find the value of the velocity when it's at 4 seconds. The value of the velocity when it's at 4 seconds will now be velocity at 4 seconds. Velocity at 4 seconds. We will written as, from the kinematic equation we have that v is equals to 6t minus 2. So it means that any place I have my t, I'm going to put what? 4. I mean 6 in bracket 4 minus 2. And 6 times 4, they give you 24. So 24 minus 2, and the answer is 22 meter per second. We've actually answered the first question. Solving the second question, which is, at what time will the velocity of the body become 0? So the question is, we have to find at what time, our time when the velocity becomes 0, and that means 0 meter per second. Recall that we already gotten the kinematic equation for the velocity, which is v equals to 6t minus 2, then you can put in bracket meter per second. So this was the kinematic equation we had for the velocity. So the next to do is to find the value of our time when we substitute the value of v to be 0. So that means if I put my v to be 0, then I'm going to have 0 equals to 6t minus 2. Now let's see how I can get my t. Making the t change of subject or formula, I'm going to have it as, bringing it to the other side, that's 6t equals to 2. Dividing both sides by 6, cancel out my 6, t equals to 2 here is 1, 2 here is 3. My t is 1 over 3 or 0.333 seconds. Hence, the value of the velocity is given as 22 meters per second, which is our first question, and the value of the time is given as 0.333 seconds, which is our second question. Now let's go to the option whether we have our answer. Coming down to the option, the right answer is option B. Option B, which is 22 meters per second, then 0.33 seconds.